Hello everyone, welcome back to my channel. Well, in set series we were doing the linear equations in two variables or simultaneous equations. We have seen the elimination method, substitution method and the graphical method. Today we will be seeing the consistency of pair of linear equations. How will you find whether the equation is a consistent, inconsistent, or in consistency you will get the two different ways, that is it can be a unique solution, it can be an infinite solution. So let me see this one. Consistency of a linear equation can be defined by two types. That means if you're defining its consistency, it can be consistent and it can be inconsistent. Well, if the pair of linear equations are consistent, then there are two possible ways you can get the solution. One can be a unique solution, so you can get the unique solution, and second, you can get infinite solutions. And if a pair of equation is inconsistent, then in that case you will be getting no solution. So just by looking at the equation and doing like a little bit thing, you can know whether it's a consistent or inconsistent. So let me see what condition we have to apply to know whether the equation has unique, infinite or no solution. So first is unique solution. So we know the pair of linear equation in terms of ABC. If I write, I can write it as a1x plus b1y plus c1 equals 0, and our second equation is a2x plus b2y plus c2 equals 0. Now, without solving, I have to find whether it has unique solution or not. So I just need to find their ratios, a1 over a2, b1 over b2, and c1 over c2. And I have to see that if a1 over a2 is not equals to b1 over b2. If they are not equal, then it's a case of unique solution. So let me see an example. See this question. Here, the equation is given as 2x plus 3y equals 5 and another is 3x minus 2y equals 1, and we have to see whether it's consistent or inconsistent. So first thing is I am dividing 2 over 3. Next is 3 over negative 2, like a1 over a2, b1 over b2, and as I told you, c is not important in this case. You can clearly see these two are not equals to each other. So this is the case of unique solution. You will get unique solution, that means you will get one solution for each. You will get x1 equals something, y1 equals something, and z1 equals something if it's 3 variable. So you will get each a unique solution. You cannot say that x1 can take 2 as well and 3 as well. No, you have a one unique solution for each variable. So that's the condition for unique solution. For infinite solution, let we have the same. That means a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals 0. We have two different equations. And then we have the same, we have to find the ratio of a1, a2, b1, b2 and c1, c2, and they bear this relationship that their ratio should be equals to each other. You have to find the ratio of each one of them and you have to find whether they are equal or not, and if they are equal, definitely it's a case of infinite solution. Take an example of this one, which is 2x plus 3y is equals to 1, and this is 6x plus 9y is equals to 3. Now let me find the ratio. It's 2 over 6, it's 3 over 9, That's 1 over 3, which simplified to 1 over 3, 1 over 3, and 1 over 3, which clearly are equals to each other. So this is definitely a case of infinite solution. So we have seen that the consistency is defined by consistence and being inconsistent. Inconsistent, if the solution is consistent, you will be having two different outcome. That means it can be a unique solution and it can be infinite solution. For unique solution, we have seen that the ratio of a1 and a2 should not be equals to b1 over b2. Whereas in infinite solution, the ratio of a1, a2, b1, b2 and c1, c2 should be equals to each other. Now the third is the inconsistent. That means it should have no solution. So let me see the condition of this. So same, I'm writing a1x plus b1y plus c1 represents my first equation, and a2x plus b2y plus c2 equals 0 represents my second equation. Now I have to find the ratio of a1 over a2, b1 over b2 and c1 over c2, and if they both are equals to each other but c1 and c2 are not sharing any ratio, the ratio of c1 and c2 is completely different, then this is the case of no solution. So let me see one example of it. Same, I am finding the ratio of a1 over a2, b1 over b2 and c1 over c2. I have found that the ratio of a1 over 2 and b1 b2 are exactly the same, which is 1 over 2, but the c1 over c2 is not equals. Now let me check it. We can clearly check it here. How I can check this and how can I verify that definitely it's not going to give me any solution is from first equation. I will find that 2x plus 3y is 9. If I substitute this value in second equation, that means second equation can be written as, if I take out 2 as common, this will give me 2x plus 3y equals 2. This is how I can write my equation number 2. I know 2x plus 3y is 9. So substituting here, you will get 2 into 9 is equals to 2. And is it possible that 18 equals 2? It's not possible at all. There's common intersection doesn't exist. We cannot find a common value. So this will give you no solution at all. We can also cross verify the previous ones as well. So let me try. Here, when we are talking about the infinite solution, so their ratio should be same. In this equation, this second equation can be rearranged and written as 2. If I take out 3 as common, this can be written as 2x plus 3y equals 3. And our first equation is 2x plus 3y equals 1. So I need to substitute this value. 2x plus 3y is 1. So I'm substituting it here. 3 into 1 equals 3. That means 3 equals 3. So yes, we cannot get the unique solution in this case, but yes, at least this exists. Now let me understand the graphical representation of each so that you can get a clear idea. The previous one was just to give you the condition, that these are the conditions that will help you in finding the consistency and inconsistency of any solution. But here is a graphical representation which will help you to understand these two in detail. So the first that we discussed was the unique solution. Say for example, we have these two equations, 2x plus 3y equals 5, and we have equation as 2x minus y is equals to 1. We have this one. When I represent it on a graph, my two lines would look like this. This equation would look like somehow, I'm just roughly drawing it, it would look like this. And the second equation, which is this one, this would roughly looks like this one. So you can clearly see that these two are not parallel at all. Only the first thing that I have to check it, To get a unique solution, they should intersect at one point, because there is only one point and they are sharing only one single common coordinate. You can say every point on this green line is completely different on every point on this magenta line. Only they are sharing a single common point. So that's the reason they have a unique solution. So we have to see whether they are parallel or not. That's it. And I get to know from here that my gradient, because the gradient is the thing that will help you in finding whether they are parallel or not. So when I'm finding the gradient of this, I'll get my gradient as negative 2 over 3. And in this case, my gradient is 2. So clearly they both are completely different. So if they are not parallel, they are intersecting. And this is the reason the condition for the unique solution is you have to see whether they are different or not. So say for example, while solving, you just messed up in finding like, okay, what was the condition? A1, A2, B1, B2, what was the condition? So in that case, this thing will help you in finding the answer that their gradients should be different, and in that case you will get a unique solution. The second condition is where you will find infinite solution. So same thing, if I calculate the gradient of this one, it comes out to be minus 2 over 3. And here, if I calculate the gradient, also negative 2 over 3. So they both have the same gradient. If they are sharing the same gradient, that means they can be parallel or they can be overlapping lines. Gradient, slope, which means steepness with the x-axis. What angle is it making with the x-axis? If they both share the same gradient, that means they both have the same inclination. Same inclination, that means your lines can be like this. So when I'm plotting this one, roughly it will give me, they have the same inclination when they are parallel, and when I overlap them like this, still the inclination is exactly the same. Only they are overlapping. That means they are sharing the same y-intercept, and that's why finding the y-intercept is very important. So in this case, the y-intercept is 1 over 3. Whereas in the second case, y-intercept is as 1 over 3 as well. So they both have the same y-intercept. That means they are nothing but overlapping with each other. And if they are overlapping with each other, that means clearly at every point they are sharing the common answer. So at every single point they are overlapping each other. That means each and every point are exactly the same, sharing infinite common points. And that's why the ratio should be same. So this graphical interpretation will help you in finding that even if you forgot this, that a1 over a2 should be equals, should not be equals, then in that case you should be aware of this thing, that their gradient should be same and their y-intercept should be same. So now they almost are actually the same line. They're just overlapping with each other, having same gradient and y-intercept. And moving on to our third one, which is inconsistent. That means having no solution. So our condition was that a1 over a2 and b1 over b2 should be equals, whereas c1 over c2 should be different. That means, let's say my equation be 2x plus y is equals to 4, and 2x, or I can say 4x, let's say 4x. 4x plus 2y is equals to 1. Now let me find the ratio of, according to the condition, a1 over a2, so 2 over 4 will give you 1 over 2 on simplification. b1 over b2 is also 1 over 2, so I can write a1 over a2 is half, b1 over b2 is half, but c1 over c2 is 4. So they both are equal, but this one is not equal. Let me see this, how graphically I can represent it. So Simply, graphically, when I draw this line, it would look like this. And when I represent the next one, first I have to see the gradient. If I calculate the gradient of this one, because this is the first step to know whether your lines are going to be intersecting or parallel. In the previous one, the first one where we were getting unique solution, we have found the gradient. We found the gradients are different, so they will be intersecting at one point. In the second case where we got infinite solution, we found that the gradient was same. So it can be parallel, it can be overlapping. When they have the same y-intercept, that means they are overlapping and you will find the infinite solution. Now this is the third case. First we have to calculate the gradient. From here I'll get gradient as, and from the bottom one also it's going to be as well. That means the inclination is exactly the same. For the next one, I would find the y-intercept. So y-intercept, which is c, let me see, we'll get 4, and here intercept you will get as half. That means clearly your y-intercepts are completely different. Inclination is same, but what means your line would look like this. This one. So this represents my first line, whereas this one is first line where you will get y-intercept as 4, whereas this is my second line where intercept is half. But inclination is same. So they are clearly parallel to each other. And if they are parallel to each other, that means there's no way that they can meet at any point. And if they're not going to meet at any point, that means you will find no solution. So this is the graphical representation of understanding. If you're not able to recall like the ratios A1, A2, B1, B2, this one will give you a good idea of understanding. Just let me explore few questions, and in the next video we'll be meeting with the set related questions. So this question says, find if pair of equations have unique, infinite, or no solution. So simple, we have to write A1 over A2, B1 over B2, and C1 over C2, and let's see what value will we get. So 2 over 6, it's minus 7 over minus 21, and this is 4 over 9. Simplified to 1 over 3, simplified to 1 over 3, and 4 over 9. They both are equal, but this is not equal, and this is the case of no solution. So the pair of equations have no solution. Moving on to the next question. So it says, find the value of k if the pair of equations have no solution. Where 4x minus 9y equals 2 and kx minus 18y equals 5, and we know the condition of no solution is a1 over a2 should be equals to b1 over b2 and should not be equals to c1 over c2. So that means definitely their ratio should be equals. So a1 over a2, which is 4 over k, should be equals to b1 over b2, that is minus 9 over minus 18. So 4 over k is equals to 1 over 2, and k turns out to be 8. That means the value of k should be 8 to make the solution a no solution. Now moving on to our third and the last question. Find k1 plus k2 in the following equations if the following equations have infinite solution. Well, the condition for infinite solution we know is a1 over a2 equals b1 over b2 equals c1 over c2. Well, a1 over a2 is k1 over 4 should be equals to b1 over b2, which is 3 over 9, should be equals to c1 over c2, which is 9 over k2. We cannot find all equals to at one place. We have to take two at one time. That means like these two one time, two fractions one time. So I'm just equating k1 over 4 equals 3 over 9, which is k1 over 4 equals 1 over 3, or k1 is equals to 4 over 3. This is the value of k1. Now moving on to K2, to find K2, same, I'm just now equating these two. So on equating these two, I'll get 3 over 9 is equals to 9 over K2. Our K2 is, you can say, 27. So what is K1 plus K2? It's 27 plus 4 over 3, which is 85 over 3. So this was the basic graphical representation, or algebraically how can you solve and know the consistency of any linear pairs. So that's it for today. And also, if you need one-on-one personalized classes or group classes, you can just drop us an email at akziacademy@gmail.com. The classes are at just $7 per hour. Also, if you need the mock papers, you can purchase from here at a high discounted rate. So all you need to do is just post your queries at akziacademy@gmail.com. So that's it for today. Thank you. Have a great day.